Hey guys, Miss Raymond here today to talk to you about theoretical probability. We have figured out or learned about how to find probability, and then we recently worked on finding experimental probability when you actually have an experiment where you're conducting trials. So today we're going to talk about theoretical probability. It's similar, but it's just slightly different. All right. So let's go over the key idea. This is from Big Ideas Math, Chapter 9, Section 2. When all possible outcomes are equally likely, the theoretical probability of an event is a ratio of the number of favorable outcomes to the number of possible outcomes. Okay, so you can see this is what you're going to write. So P stands for probability. Probability of the event equals the number of favorable outcomes over the number of possible outcomes. All right, so we've gone over the key idea. Now we're going to look at Big Ideas, example 3 from chapter 9, section 2, finding theoretical probability. All right, so here is our example. And it says you randomly choose one of the letters shown. So here are the letters, right? What is the theoretical probability of choosing a vowel? Okay, so again, you're going to use P, or probability of the event, equals the ratio of favorable outcomes over possible outcomes. So you need to go over here and look at your blocks, your letters. How many are vowels, right? Because we are finding the probability, theoretical probability of choosing a vowel. So in theory, what is the probability of choosing a vowel? Well, we got to count how many vowels. So we got 1, 2, 3, right? 3 vowels. So that number goes on top. There is a total of 7 letters. So that goes on bottom, right? So it's 3 over 7, the ratio of 3 over 7. So the probability of choosing a vowel is 3 over 7. Or if you were to take 3 and divide it by 7, okay, and you would get a decimal, 0.43, or 43%. So the probability is about 43%. All right. All right. So, whoops. All right, so we've gone over example 3. We're gonna go over example another example, excuse me, a tutorial. So let me go ahead and get that.
Are placed in a hat. You randomly choose a letter from the hat. What is the theoretical probability of choosing a vowel? The problem asks us to find the theoretical probability of an event, so let's talk about that. When all possible outcomes are equally likely, the theoretical probability of an event, written in this way with a capital P and the event in parentheses, is given by the ratio of the number of favorable outcomes to the number of possible outcomes. So here's a formula for the probability, and there's also a condition that all possible outcomes are equally likely. So let's see if we can use this to find the theoretical probability mentioned in our problem. First, let's write the letters in the word Jackson. The problem says that each of these letters was placed in the hat. Then you randomly choose a letter from the hat. Are all of the outcomes equally likely? Well, assuming each letter was written on a piece of paper that's about the same size, then yes, all the outcomes are equally likely. So we can use the formula for the theoretical probability of an event. First, let's write the formula. The theoretical probability of an event is equal to the ratio of the number of favorable outcomes to the number of possible outcomes. So in our problem, we're interested in the theoretical probability of choosing a vowel. And for this situation, the number of favorable outcomes is the number of vowels. So let's count the number of vowels in these letters. We have an A and an O, and those are the only two vowels, so there are two. The number of possible outcomes is the total number of letters, so let's count the total number of letters. There are 1, 2, 3, 4, 5, 6, 7. So the theoretical probability of choosing a vowel is 2/7. Notice that this can also be written in decimal form by dividing 2 by 7, and what you get is a non-terminating decimal that's approximately equal to 29/100ths. And 29/100ths can also be written as 29%. So to answer the question, we can say the theoretical probability of choosing a vowel is 2/7 or about 29%.
All right, so we are back and we're going to look at on your own problem from Big Ideas Math. We're going to look at on your own problem number 3, which says in example 3, what is the theoretical probability of choosing an X? So we need to go back and look at example 3, which is here. This is example 3. So let's look and see how many X's do we have? All right, it should only be 1, right? And then we need to know our total number of possible outcomes. And we have 1, 2, 3, 4, 5, 6, 7. All right, so you need to remember 1 and 7. So, all right, so let me go ahead and write that down so we don't forget. All right, so we are finding the probability of choosing, the theoretical probability of choosing an X, right? So that would be equal to 1/7 because there was only one X, right? And then the 7 was the total number, right? So this is your favorable. So your favorable outcomes over your possible, right? Right, so we said that was 1/7, right? So the theoretical probability of choosing an X is 1/7. And if you wanted to divide that, if you divided 1 by 7, you would get approximately 14.3%. If you were to divide it and get a decimal and then change the decimal to a percent, then it would be approximately 14.3% or 1/7. All right. So here's your example, 1/7 or about 14.3%. All right, so we are going to move on, and this is where I would ask you to pause the video if you don't have paper and pencil, because you're going to need that, because I want you to try to work out these problems, and we will go over the answers, okay? This is a little mini assessment, and we're going to use the spinner here to determine the theoretical probability of the event, okay? So as you can see, our spinner has numbers and it also has colors on it. So the first question is asking us to determine the probability of purple, spinning purple. What is the theoretical probability of the event of spinning purple? So they already got it set up as probability of purple, right? And remember, we're putting your favorable outcomes over your possible outcomes, right? That's what you're always going to be looking at, right? The favorable outcomes over possible outcomes. All right, so we need to look at our spinner and see how many purple sections are on our spinner. I only see 1, right? So That's going to go on top because that's our favorable outcome. And how many color sections are there total? 1, 2, 3, 4, 5, 6, right? So that would be your possible outcomes. That's your bottom number. So your probability of spinning purple would be 1 out of 6. Now, if you wanted to, you could divide that and get it as a percent. Most of the time, you don't need to. You can just leave it as 1 out of 6. In this case, if you were to divide it, you would get approximately, that would be approximately 0.167. So if you were to divide 1 by 6, which would be about 16.7%. Okay. All right, so hopefully that was the answer that you got for that one. We're going to try a couple more. All right, so using the same spinner to determine the theoretical probability of the event, this time we're finding the probability of spinning a 3, right? So as you will remember, right, hopefully by now we remember that we are finding your total number when you're doing your probability of your event, right? It's always going to be your favorable outcome over your possible outcomes, right? So in this case, you have to look over at your spinner and see how many 3s that there are, right? So I only see 1. So I'm going to put that on top. So 1, and remember on the bottom, this P stands for possible outcomes. So 1, 2, 3, 4, 5, 6. I see 6. So again, your probability of spinning a 3 is 1 out of 6, which happened to be the same as for purple, right? All right, let's go ahead and let's look at, I believe we have one more assessment problem here. So for your last problem, use the spinner to determine the theoretical probability of the event of spinning an even number, okay? So I want you to go ahead and try that. Remember, just as a reminder, I'll just write it up here at the formula. Probability of your event equals favorable outcome over your possible. Oops, pen is hard to use, right? All right, so you can go ahead and start working on figuring out that problem, and then we will go over it. Okay. All right, so I'm going to give you a minute to work on that, and then we'll go over it. All right, so even numbers. So you need to go, right? Hopefully you figured out you've got 1, 2, and 3, right? So 3 goes on top because that is a favorable outcome. That's what you're trying to figure out, the theoretical probability of the event. So it goes on top, and then on the bottom is your total number of possible outcomes. So 1, 2, 3, 4, 5, 6. So 3 over 6. Now we should always simplify. We've talked about this before. If you can simplify, so I know 3 and 6. Well, I know 3 can go into 6. So I want to simplify my probability here, my ratio. So 3 divided by 3 gives me 1, and 6 divided by 3 would give me 2. So theoretical probability spinning an even number is 1 out of 2, which we know is pretty good odds, because 1 out of 2, if you divide 1 by 2, that's the same thing as 50%, right? So you got a 50-50% chance here. All right. So hopefully you learned a little something about theoretical probability. There are answers all together if you want to be able to check your answers, excuse me, all at once. So the probability, theoretical probability of spinning purple was 1 out of 6. Theoretical probability of spinning a 3 was 1 out of 6. And theoretical probability of spinning an even number was 1 out of 2. All right, so I believe you have some practice that you can do on iexcelmath.com, and hopefully you will have received the written work so you can do the practice lesson as well. All right, that's all I have for today.